let's look at a related rates problem. A spherical snowball, here's my snowball, is melting in such a way that the radius is decreasing at a rate of 0.2 centimeters per minute. So the radius is changing with respect to time at negative 0.2 centimeters per minute. It's getting smaller. At what rate is the volume decreasing? What's going on with dV dt? When the radius is 18, the radius is 18 centimeters. Okay, so I have this snowball and it's melting. And the change in the volume, I want to know how much snow is melting off of this snowball. And I know the radius is currently 18 centimeters. And I know the rate at which the radius is getting smaller. It's decreasing at a rate of 0.2 centimeters per minute. Let's take the volume equation. Volume of a sphere is 4/3 pi r cubed. And if I know the rate with respect to time for the radius, and I want to know how the volume is changing with respect to time, I should be taking the derivative of both sides with respect to t. Taking the derivative of v gives me the derivative of volume, the change in volume with respect to time. That right side's looking a lot like the power function with that r cubed. If that 3 drops down, I'm going to put it by the 4 for now. You could just cancel the 3's in one step, though. And then if I take 1 away from the power, that 3 came down, this becomes a 2. Now on this side, I have to be careful because I took the derivative with respect to time of a variable r. So this picks up a dr dt. This is what I'm trying to find, dv dt. What I know is the change in my radius. So let's plug in everything we know. The change in volume with respect to time. I'm going to go ahead and cancel out those 3's to get 4 pi. I know the radius is 18, so I'm going to plug 18 in for r squared. And I know that the radius with respect to time is changing at a rate of 0.2. Okay, so I take the 18 squared, I get 324. And now I'm just multiplying all the numbers together. Let's go ahead and multiply the 4, 324, and negative 0.2. So the 4, the 324, and the negative 0.2. And that gave me pi times negative 259.2. Let me write that a little bit cleaner. That's a change in the volume with respect to time. If I multiply that out, I get that it's changing at a rate of approximately negative 814.3. My units here are centimeters for the base sort of dimension, but it's volume, so 3, so centimeters cubed. With respect to time here being measured in minutes. So kind of a fun problem. Their language there, at what rate is it decreasing? I would say it's decreasing at that rate of 814.3. Decreasing is loaded language that tells us that we're already dealing with a negative. So it'd be kind of a double negative if I put a negative here. That's why they're saying write it as a positive number. Kind of a just linguistic thing more than a mathy thing there. Okay. Looking forward to doing more problems with you. As always, let me know if you have any questions.